Okay, so this is a quadratic equations with complex roots. Okay, so for example, the equation a z squared plus b z plus c has roots given by the following equations, basically the minus b formula. Now remember, this part here, if this part here is smaller than 0, you're then getting the square root of a negative number. This means you're going to be dealing with complex roots. If you have the square root of a positive number or 0 or above, greater than or equal to 0, you're dealing with real or equal roots. Okay, so just remember that. Now, moving on from that, the conjugate root theorem. Okay, so if you solve a quadratic equation, okay, if the coefficients of the polynomial equation are real, so an example would be something like 2z squared minus 3z, I don't know, plus 4. I'm sorry, plus 17, let's say. Okay, so the roots of this equation here are going to be, first of all, b squared minus 4ac. We can check out what that is. Okay, so b squared is minus 3, and then it's minus 4 times 2 times 17, and we can see right away that this is going to be less than 0, so it's going to be a complex root. Okay, and the fact that it's a complex root, okay, when we solve this, because that's going to be less than 0, what's also happening is when this means that the polynomial equations are real, the coefficients are real. What this means is these numbers are real, 2, 3 and 17, they're all real numbers. This means that the complex roots occur in conjugate pairs. So when you do the minus b formula for this equation here, you'll get this is maybe one root and this one is the other root, or minus 2 minus 5i is one root, then minus 2 plus 5i is the other root, or a plus bi, then a minus bi. Basically, they have to occur in pairs. The conjugates are always the two roots are always one and then its conjugate. Okay, so look, you'll figure it out more that when we start to do some questions. Okay, so an example would be, these are examples of obviously just simple quadratic equations. Okay, so what we can do here is we might do number 6 and maybe number 9 here. Okay, so 6 and 9, and maybe do 3 as well, 3, 6, 9. Okay, so what happens with this one is we can see that a is 1, b is 10, and c is 34. Okay, so you can see that that's happened. We're going to do the minus b formula, minus 10 plus or minus the square root of b squared, which is 100, and then it's minus 4ac, so minus 4 times 1 times 34, and to my knowledge that would be minus 136, all divided by 2 times 1, 2a in the bottom, which is 2. It's going to be minus 10 plus or minus the square root of minus 36. The square root of minus 36 is root 36 by root minus 1, which is going to give me 36i. Oh, sorry, not 36i, 6i, because square root of 36 is 6. So it's going to be 10 plus or minus 6i over 2. And what we see is that when we divide by 2, we're going to get minus 5 plus 3i, and then minus 5 minus 3i. As predicted, the conjugates are the two roots. Okay, now I'm going to show you something else while I'm here. If you're given the roots and you want to find the initial equation, so imagine we were given the answer. Here are the two roots of an equation whose coefficients are real, and you want to find out what was the initial equation. Well, to do this, there's a formula. Okay, so we say z squared minus sum of the roots. Now sum of the roots means you add it together. Okay, times z, and then at the end it's going to be plus product of roots. Now what happens here? Equals 0. So we have z squared. Now when we add the two roots together, we're going to get minus 10, because the 3i cancels with the other 3i. So it's going to be minus 10 times z. Now we're going to do the product of the roots. Product of the roots means you multiply them. So you're going to get minus 5 plus 3i minus 5 minus 3i. When you multiply these in, you're going to get 25. You're going to get plus 15i minus 15i. And then it's going to be minus 9i squared. And then minus 9i squared, same thing, is plus 9. The 15's cancel. 25 plus 9, 34. So plus 34 at the end. And we can see that the minus 10 turns out to be plus 10z plus 34 equals 0. And to knowledge, that's it. That's the initial equation. So I'm just showing you how to go backwards, okay, if you need to do that. Now, I've shown you how to go backwards. We're going to continue on with question 6. Now, question 6, same deal as last time. We just have to figure out what A, B, and C are. So all these numbers are real. So the number 5, 2, and 10 are real. So we're going to get a. If the roots are complex, they're going to occur in their conjugates. Okay, so that's going to be 5 minus 2 and 10. Do the minus b formula again, so it's going to be minus b. So minus b is going to be plus 2. So it's going to be. I'll just keep the minus b formula up the top here. And then let's do this. So it's going to be minus b, which is going to be plus 2, plus or minus the square root of. Now b squared is going to be 4, because minus 2 squared is 4, minus 4ac, which is going to be 4 times 5 times 10. So that's going to be minus 200 all over 2 times 5. So then we're going to have 2 plus or minus, and now this is going to be the square root of, I think it's minus 200 plus 4, or 4 minus 200. 4 minus 200 is root 196. And root 196 equals 14. So it's going to be 14i, because root minus 196 is going to be 14i. Okay, so 2 plus or minus 14i all over 10. Then we got to split the fraction, so it's going to be 2 over 10 plus or minus 14i over 10, and then the answer to that is going to be a fifth plus 7/5 I, or a fifth minus 7/5 I. Now, once again, I'm going to show you how to go backwards on this. So it's going to be z squared minus sum of roots times z plus product of roots equals 0. So when we add these together, we're going to get a fifth plus a fifth, which is 2/5, and 7/5 I minus 7/5 I just cancels, so it's going to be z squared minus 2/5 z. And then the product, we're going to have to multiply these by each other. So we're going to get is so the two of them here are going to get multiplied by each other. So there we go. So what happens is we get a fifth by a fifth, 1 over 25. 1/5 by minus a seventh is going to be minus 7 over 25i. Then the next one's going to be plus 7 over 25i. Then we're going to have 7 over 5 multiplied with 7 over 5, which is minus 49 over 25i squared. And then they cancel. And then what we have here is that's going to be turned into plus 49 over 25, because that I squared counts as minus 1. And then we're going to have 50 over 25, which equals 2. So we're going to have a 2 at the end here. Now, this 5 on the bottom, we got to put everything over 5. So that's going to be 5z squared over 5. And this is going to be 5 multiplied by 2 all over 5. And then finally the 5's on the bottom cancel. You're going to get 5z squared minus 2z plus 10 equals 0. Back to the original equation. Once again, you don't have to go back to the original equation, but you might need to know how to go backwards. Now, moving on to number 10. And number 10 is very similar to 8 and 9. Okay, so number 10, z squared equals minus 100. You can see that it's minus 100 there, so then z is going to be equal to the square root of minus 100. The square root of minus 100 is going to be, okay, so with this one here, you got to remember that it's going to be root 100, and then square root of minus 1. And please remember that root 100 can be plus or minus 10. So it's going to be plus or minus 10i. Okay. Now that usually doesn't matter in the minus b formula because you have a plus or minus b squared minus 4ac anyway, so you don't need to count the plus or minus. But when for these questions here, you actually have to make sure that when you square root a number, you put the plus or minus value in. So for example, with question A, the answer here would be z squared equals minus 9, z equals root minus 9, which is root 9 by root minus 1, which is going to be plus or minus 3i. Okay, so p and k are real numbers such that p multiplied by this plus 8 minus ki equals 5k minus 3 minus I. Find the value of p and the value of k. And this is going to be 2p plus pi plus 8 minus ki equals 5k minus 3 minus I. Then we're going to mark off the real numbers here, so we have a real, and real. So we're going to have 2p plus 8 equals 5k minus 3. Bring the 5k over, minus 5k plus 2p. And then bring the 8 over the other side equals minus 11. And then what we're going to have next is the imaginary equation. P minus k equals minus 1i, or minus 1, or minus k plus p equals minus 1. Okay, I'm going to multiply the bottom one by minus 2, and what I should get here is 2k minus 2p equals 2. Then we're going to get minus 5k plus 2p equals minus 11. Add them together, minus 3k equals minus 9, k equals 3. Now that we know that k equals 3, we can replace this k with 3. Minus 3 plus p equals minus 1. P therefore must be equal to 2. Therefore this equation, or this answer, is going to be p is 2. 2 plus 3i. Investigate if 2 plus 3i is a root of this equation. Well, I know how to solve these equations, so what I can do is just do the minus b formula. So you say that's 1, 4 and 3, a equals 1, b equals minus 4, minus b equals plus 4, and c equals 13. So it's going to be plus 4 plus or minus the square root of b squared, which is 16, minus 4 times 1 times 13, it's going to be minus 52, all over 2 times 1, 4 plus or minus the square root of minus 36, all over 2, then it's going to be 4 plus or minus root 36 times root minus 1, all over 2. That's going to be 4 plus or minus 6i all over 2. That's going to be 2 plus or minus 3i. So the two answers are 2 plus 3i and 2 minus 3i. So investigate if it is a root. Okay, so that's correct. Now number 12. Solve the quadratic equation, this one here, and explain why the roots do not occur in conjugate pairs. Well, the roots do not occur in conjugate pairs because the coefficients, which are a equals 1, b equals minus 2 bracket 1 plus I, or b is equal to minus 2 minus 2i, and c is equal to 4 plus 2i. These numbers aren't real, therefore they're not going to occur in conjugate pairs. However, we still have to solve this. Okay, now to solve this, what we're going to do is we're going to go into we're basically going to do the minus b formula. Minus b plus or minus square root of b squared minus 4ac all over 2a. Now, what's going to happen here is we're going to get b. If that's b, then minus b is 2 plus 2i. So we're going to get 2 plus 2i plus or minus the square root of, now b squared is basically minus 2 minus 2i multiplied by minus 2 minus 2i. So we're going to get 4 4 plus 4i plus another 4i plus 4i squared. 4i squared turns to minus 4, so it's going to be 4 minus 4, which cancels. That's just going to be 8i. So the b squared part is 8i. Okay, and now we're going to do the minus 4ac. So minus 4 times 1 times c, which is 4 plus 2i. So what we're going to get here is minus 16 minus 8i, which is interesting. So minus 16 minus 4 times 1 minus 16 minus 8i. And then that's all going to be over 2 times 1. And then when this happens, we're going to get 2 plus 2i plus or minus the square root of minus 16. The square root of minus 16 is root 16 times root minus 1, which is 4i all over 2. So we have two different equations here. We're going to have 2 plus 2i minus or plus 4i over 2, or we're going to have 2 plus 2i minus 4i all over 2. So this time we're going to get 2 plus 6i divided by 2. It's going to be 1 plus 3i. Then the next one is going to be 2 minus 2i all over 2, which is going to be 1 minus I. Okay, so here's my two roots here. Okie dokes. Okay, so now we have question 15, very similar to number 12 we just did there a second ago. So a equals 1, b equals, we're just going to multiply that in. We're going to get minus 2 minus 5i, so then minus b has to be plus 2 plus 5i. C being 5i minus 5. And then we're going to do the minus b formula. So we're going to get, in this case, we're going to get minus b is 2 plus 5i. 2 plus 5i plus or minus the square root of b squared. So we have to find out what b squared is. So it's going to be minus 2 minus 5i into minus 2 minus 5i. So we're going to get 4 plus 10i plus another 10i plus 25i squared, which is minus 25. So we're going to get minus 21 plus 20i. So that's going to be minus 21 plus 20i. Now we got to do the minus 4ac part. So it's going to be minus 4 times 1 times c. C in this case is 5i minus 5. And then that's going to be minus 20i, because that one doesn't really count there. And then it's going to be minus 20i plus 20. So minus 20i plus 20, all divided by 2 times 1. What we're going to get here is that the 20i's cancel, and we're going to get the square root of minus 1, because the minus 21 plus 20. Then we get 2 plus 5i all over 2. Now the square root of minus 1, as we all know, is 1i. So 1i. And then we got to break up both answers, okay? So the first answer is going to be 2. Remember, 5i take away plus i is 6i, so 2 plus 6i over 2. The next one is going to be 5i take away an i, so it's going to be 2 plus 4i over 2. So our two answers are going to be 1 plus 3i and then 1 plus 2i. Okay.